Okay, calculate the intensity of the sun's radiation on the surface of Mercury and Jupiter, right? For Earth, it's 1380 watts per square meter, right? And then, of course, the brightness is the luminosity divided by 4 pi d squared, right? So we can use the ratio of d squared to get the intensity at Mercury, right? The Earth is, what does it say? Orbit's drawn. Oh, I see. The units are 10 to the 10th. So here's the diagram in the book, right? And they say that Mercury is 5.7 times 10 to the 10th meters, right? Jupiter is 77.8 times 10 to the 10th. And of course, Earth is at 15 times 10 to the 10th, right? Right. So these are just arbitrary units, right? 15 times 10 to the 10th. These are all times 10 to the 10th, right? Okay. So at Mercury, it's got to be bigger, and it's got to be bigger by a ratio of these guys, but squared, right? So to figure out Mercury, we're going to go 1380 watts per square meter. It's got to be more at Mercury because Mercury is closer. It's got to be the ratio of the distances squared, so I'm going to go 15 squared divided by 5.7 squared. Right? So 1380 times 15 squared divided by 5.7 squared. And I get 955.7. 9556.7. Okay? I'll go 9557 watts per square meter. Now, why do they have 9552? Is that a typo? No, that's in the book. So, they're just wrong again. I don't know. Maybe they're using like 1400 or something like that, right? Okay. So no, that wouldn't do it. So anyway, that's that. Okay, so let's suppose I'm going to play by the rules and do this, exactly the way I should, right? Okay, the brightness of Mercury, right, is going to be brightness is going to equal the luminosity of the sun divided by 4 pi times 5.7 times 10 to the 10th, right, squared, right? Okay, we don't know the luminosity of the sun, right? And the brightness of Earth, that's Mercury, right? BM. Okay, the brightness at Earth is equal to the luminosity of the sun divided by 4 pi times, 15 times 10 to the 10th, right, squared. And then, of course, if we divide BM by BE, yeah, BM by BE, we end up with, well, all this cancels, right? Right? So B of M divided by B of E ends up being, well, notice that it's 1 over, right? We're dividing this thing, right? And so you end up with that it's 15 times 10 to the 10th, that quantity squared, right, divided by, 5.7 times 10 to the 10th squared. And that's how you end up with this whole relationship that we did here, right? Because then I can multiply this by the brightness at Earth, and you end up with the brightness at Mercury, and that's how this thing comes out. Notice that the 10 to the 10ths go away, and that's why I can be a little cheeky monkey and just do this, right? Okay, so now let's figure it out for Jupiter. We'll do the same thing. We'll go 1380. It's got to be not as bright at Jupiter, right? So I'm going to go Earth squared over Jupiter squared. Okay, so 1380 times 15 squared divided by 77.8 squared. And I get 51.3 watts per square meter. Okay, so now I'm puzzled. Let's see. 15, Mercury's 5.7. Yeah, I don't know why I got a different number. Well, this number is 1 part in 1,000, so I'm not really too worried about that. Yay.